This is a calculus pre-lecture series. I'm Caitlin Murphy, and this podcast is on properties of differentiation. First, recall that we calculate the derivative of a function f using the formula found here. D dx of f is equal to the limit as h approaches 0 of f of x plus h minus f of x over h. So we can manipulate this formula a little bit for different functions f in different situations to come up with some general properties of differentiation. For instance, if our function f of x is a constant function, so it maps everything to some constant c, and we use this formula, we see that d dx of f is equal to the limit as h approaches 0 of f of x plus h, but that's just going to be c, minus f of x will also be c, it's a constant function, over h, but this is just the limit as h approaches 0 of 0 over h, which is the limit as h approaches 0 of 0, which is just 0. So if the function f is just a constant function, then its derivative will just be 0. Also, if we have a function f of x and we're taking the derivative of a constant multiple of that function, so consider here we have k times f of x, we could calculate the derivative using this formula. So you have d dx of k times f of x, or k times f, and that will be equal to the limit as h approaches 0 of k times f of x plus h minus k times f of x over h. But we can factor that k out of the top, so this is just k times the limit as h approaches 0 of f of x plus h minus f of x over h. But notice now this portion, this limit as h approaches 0, f of x plus h minus f of x over h, that's just the derivative of f of x. So this whole thing is just equal to k times the derivative of f of x. So if we have a constant multiple of a function, we can actually pull that constant multiple out before taking the derivative. And we have these properties for a lot of different specific functions f, and we can see them in this table. So if we have f and g that are differentiable functions, then the following formulas hold. There are 8 properties here that we're going to need to get pretty familiar with over our time practicing calculus. So it'll definitely be worth the time to study these different properties. So let's attempt to use these properties to differentiate here. We want to find the derivative of 3x to the 5th plus 5x squared minus 10. So the first thing we're going to do is notice that we kind of have 3 different terms in here. And the sum property tells us that we can pull these apart and take the derivatives of the terms separately and then add them together. So this is equal to the derivative of 3x to the 5th plus the derivative of 5x squared plus the derivative of negative 10. Then that constant multiple property tells me that I can pull out 3 times the derivative of x to the 5th plus 5 times the derivative of x squared. And we'll just keep our derivative of negative 10 at the end. Then I can go ahead and differentiate. So this will be 3 times 5x to the 4th plus 5 times 2x to the 1st plus the derivative of constant is just 0. And that simplifies to be 15 x to the 4th plus 10x as our final derivative.